Hello and welcome. Let's get started with the introduction to the computer vision. So, what is computer vision? In simple words, computer vision enables computers and machines to see the visual world just like the way humans see and understand their environment. Computer vision is a type of artificial intelligence that enables computers to derive meaningful information from images, videos, and other visual inputs, to interpret and analyze the visual world, and take actions or make recommendations based on that information. As you may know that artificial intelligence enables computers or machines to think, where computer vision enables computers to see, observe, and understand. Are you familiar with this phrase, every picture tells a story? The phrase every picture tells a story emphasizes the idea that visual information captured in an image can convey narrative or convey meaningful information. It applies to both human vision and computer vision, but in slightly different ways. For a human vision, when humans look at a picture, they have the ability to interpret the visual elements, recognize objects, understand relationships, and derive meaningful information from the overall composition. Our visual perception is influenced by our experience, emotions, and culture background, allowing us to create a narrative or story in our minds based on the visual cues present in the picture. We can infer context, emotions, and subtle details that contribute to storytelling aspect of the image. In the context of computer vision, the phrase every picture tells a story highlights the goal of extracting meaningful information and understanding from images using AI algorithms, machine learning, and deep learning techniques. Computer vision algorithms are trained to analyze images and recognize patterns, objects, and other visual elements. By analyzing the pixels and feature in an image, computer vision systems can extract information and make inferences about the content of the image. This may involve tasks such as object detection, image classification, and scene understanding, etc. So the goal of computer vision is to write computer programs that can interpret and understand images and their context. So the computer vision enables computers to understand and interpret images and videos, much like the human vision system. For example, in this image, enable computer what kind of scene it is, where are the cars, where are the trees, and what other objects exist in this image, and how far is the building. So the computer vision enables the computers to understand the image like that, as a human can interpret the information and see the image. Computer vision aims to replicate and enhance human vision capabilities by using cameras or other imaging devices to capture images or video streams. These images are then processed, analyzed, and interpreted with computers using various algorithms and models to perform tasks such as image recognition, object detection, image segmentation, tracking, and much more. Vision is an amazing feat of natural intelligence. Visual cortex occupies about 50% of brain, more human brain devoted to vision than anything else. Computer vision works much the same as human vision, except humans have a head start. Human sight has the advantage of lifetime of context to train how to tell objects apart, how far away they are, whether they are moving, and whether there is something wrong in an image. Computer vision trains machines to perform these functions, but it has to do it in much less time with cameras, data, and algorithms rather than retinas, optic nerves, and a visual cortex like the humans have. Because a system trained to inspect products or watch a production asset can analyze thousands of products or processes a minute, noticing defects or issues, it can quickly surpass human capabilities. Human vision is a complex biological system that relies on eyes and the brain working together to process visual information. Humans have a high level of visual perception and can easily recognize objects, understand scenes, and interpret context. Human vision is highly adaptive and can handle variations in lighting conditions, occlusions, and complex backgrounds. Human can make judgments about objects' properties such as their color, shape, texture, size, and relative positions. Humans can quickly focus their attention on specific regions of an image and extract relevant details. Computer vision systems rely on algorithms and computational techniques to analyze and interpret visual data. Computer vision system can detect and recognize objects, but the level of accuracy and the performance depends on the specific algorithm and models used. Computer vision algorithm can quantify and measure visual features such as color, histograms, gradients, edges, corners, or textures. Computer vision algorithms are sensitive to variations in lighting conditions, noise, occlusions, or complex backgrounds, and may require pre-processing techniques to enhance the images. Computer vision systems lack the intuition and contextual understanding that humans possess. For a computer, an image is a digital representation of visual information, typically stored as a two-dimensional array of pixels. Each pixel represents a single point of the image and contains information about its color or intensity. Computers process images as numerical data where each pixel is assigned a value that corresponds to its color or grayscale level, and then computer vision algorithms operate on these digital images, analyzing the pixel values and patterns to perform tasks such as object detection, image recognition, segmentation, or feature extraction. The algorithms can interpret the pixel values using mathematical operations, machine learning, and deep learning techniques to extract meaningful information from the image data. So the digital images are represented in the form of pixels so that computer can understand. A pixel, also known as picture element, is the smallest unit of a digital image. It is a single point in an image grid or matrix representing a specific location and color value. So a pixel contains information about the intensity or color of the corresponding point in the image. Now let's have a look at the brief history of computer vision. In 1966, Marvin Minsky at MIT asked his graduate students to spend the summer linking a camera to a computer and getting the computer to describe what it saw. We now know that the problem is slightly more difficult than that. Then in 1970s, some progress on interpreting selected images. In 1980s, artificial neural networks come and go, shift towards geometry and increased mathematical rigor. In 1990s, face recognition statistical analysis in vogue. In 2000, broader recognition, large annotated dataset available, video processing starts. And nowadays, we can see a lot of computer vision applications in our real life. For example, in the smartphone application, you can detect faces, you can generate a panorama, etc. Computer vision has a wide range of potential real-life applications across various fields, such as self-driving vehicles, military applications, event detection, industrial automation, agriculture equipments, medical image processing. Computer vision plays a vital role in the development of autonomous vehicles. It enables the vehicles to perceive and understand its surroundings, recognize objects, and make informed decisions for safe and efficient navigation. Computer vision is used to detect and classify various objects in the environment, such as pedestrians, vehicles, traffic signs, and obstacles. This information helps the autonomous vehicles understand its surroundings and make appropriate decisions. Computer vision is employed to detect and track lane markings on the road. This enables the autonomous vehicles to stay within its designated lane and navigate safely. Computer vision is used for optical character recognition to convert scanned documents to text. For example, digital recognition from the images and license plate readers. Computer vision is used for face detection. Nowadays, many new digital cameras can detect faces. Computer vision is used in supermarkets for object recognition. In the supermarket, a smart camera is flush mounted in the checkout lane, continuously watching for items. When an item is detected and recognized, the cashier verifies the quantity of the items that were found under the basket and continues to close the transaction. You can use computer vision for biometrics. You can read a story on the Wikipedia how the Afghan girl was identified by her iris patterns. You can use the computer vision to log in without a password to your devices. For example, fingerprint scanners or many new laptops and smartphone devices. And also face recognition systems now beginning to appear more widely to log into your device. Nowadays, computer vision based object recognition is used in mobile phones. Computer vision techniques can be used to create various visual effects and image manipulations. For example, special effect like shape capture is used in Matrix movies, and special effect like motion capture is used in Pirates of Caribbean and Avatar movies. You can observe the vision-based systems in smart cars like BMW, GM, Volvo models. You can play the interactive games using computer vision-based Kinect device. Vision systems like GPL used for several tasks in space, for example panorama stitching, 3D terrain modeling, obstacle detection, position tracking, etc. Similarly, vision-based industrial robots, vision-based mobile robots such as NASA's Mars Spirit rover, and computer vision is also used for medical imaging such as 3D imaging, MRI, CT scans, and image-guided surgery. So these are just a few examples of the diverse applications of computer vision. Its potential is vast and it continues to evolve, offering innovative solutions in various fields. In the next lecture, you will go through the introduction to deep learning, because more recently deep learning techniques have emerged as a powerful new tool providing flexibility and high levels of accuracy for computer vision applications. See you in the next lecture.